with the discussion of the chemistry of life, biomolecules. I told you on page on page 76 of your notebook to write up at the top macromolecules, because that's what we call these biomolecules. They are macromolecules. So our objective in this chapter is we're going to talk about 4 different types of macromolecules. We're going to talk about carbohydrates. I'm sure you've heard of some of these. Heard of carbohydrates before? What about proteins? What about lipids? What about nucleic acids? I'm sure we've heard of all of those, but we are going to go a little bit deeper into our discussion of those. So we're going to talk at a little more depth. So you should be able to tell me some things about those 4 things. Okay? You should be able to tell me some stuff about today. Today our goal is to be able to differentiate between a hydrolysis and a dehydration reaction. So you should be able to tell me by the time we're done taking notes today, what is the difference between dehydration and hydrolysis? Okay. What are macromolecules? Okay. What are macromolecules? Living cells are made of many large molecules called macromolecules. Okay. And we have up there a little way to remember. Big Mac. Okay, Big Mac. So macro just means they are big molecules. Okay. So macromolecules are big molecules. Because they are necessary for life, they are also sometimes called biomolecules. Because we know based on our prefix-suffix vocabulary, what's bio? What's bio? Life. Biology, the study of life, that's what we're in here. Okay? So biomolecules is the study of the molecules for life. Okay? The word organic also means living, so you may even see them called organic molecules. Biomolecules are big structures that are made of smaller units, made of many smaller units, called monomers. We can say that these monomers are the building blocks of the macromolecules. So a monomer is the small unit that makes up these big biomolecules. And we'll talk about the monomers for each one of the 4 that we discussed. Okay? Monomers are the Lego. Monomers are the Lego pieces that, when put together, make a big macromolecule. Okay? You ever play with Legos when you were a kid? Yeah, no? Okay. My little godson had tons of these. I mean, it would take us, we would sit down when I would sit down with them and spend like 4 hours building these complex cities of Legos. And he loved to do it, so we just sit down and do it. But each little block of the Lego is like the monomer, and the whole big city that we built would be what we call a polymer, which is the macromolecule. We're going to talk about 4 main macromolecules. I already hit on these. Proteins, nucleic acids, carbohydrates, lipids. Okay, you don't have to worry about those pictures that I have up there. We'll be making picture of these later on that are a little bit better. Just make sure that you have the 4 main biomolecules down in your notebook. Proteins, nucleic acids, carbohydrates, and lipids. Now, we said that each one of these biomolecules are monomers that are put together to make a bigger structure. Okay? Well, how do we make biomolecules? If you remember, just not too long ago, I referenced a polymer. Okay? Polymer. Anybody know what poly means? Like a polygon? Huh? Many. Okay? Poly is many. So literally, a monomer is one, a polymer is many. So when you see right here it says a monomer is the one Lego piece, a polymer is the big Lego castle, the big city I was talking about. So we put many of these monomers, these building blocks, together to form a polymer. It says when we are growing, we need to make big macromolecules for our body. We do this by putting the building blocks we have in our body already together. Monomers join together to form polymers by removing water. When you pull the water out, it allows the 2 parts to join together. This process is called dehydration synthesis. So if I'm looking at this little chain down here, okay, if I'm looking at this little chain there, we have different spheres, different circles of different colors. Each one of those spheres represents one monomer. So if I look, this polymer has how many monomers connected together? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different monomers connected together. Now, how did each one of those connect together? By a dehydration synthesis reaction, okay, where water is removed. Now, if you look at this, this says right here, you might not be able to read it. It says the links are covalent bonds. So those are covalent bonds right here, each one of those links. Okay? Can we understand the difference between a polymer and a monomer? Do we understand that? Give me a thumbs up if you got that. The difference between a polymer and a monomer. You okay? Polymer, monomer? Okay. Thumb up then. Now, this dehydration synthesis here, when joining 2 monomers together, you remove the H from one monomer and the OH from another. This forms water that is removed and the 2 monomers join together. So if I'm looking at this here, folks, if I'm looking at this and I circle this part right here, what is 2 H's and 1 O? H2O, that's what? Water. So that is this right here that is given off, a dehydration. You are removing water. And when we remove the water, look at here. We have this linking the two monomers together. So the two smiley faces are monomers. The dehydration reaction links the two monomers together. Okay? Remember, down at the bottom there, remember to dehydrate means to remove water. Okay? If you are dehydrated, what do you need to do? Consume some more water. Okay? A lot of these athletes, when they get dehydrated, drink that thing they call Gatorade, right? What do you think they're doing with the Gatorade? Rehydrating. Okay? So if you remember, dehydrate means that you are lacking water. Okay? You should be able to remember that dehydration, synthesis, means that you're taking water out. Okay? You are taking water out. How do we break down molecules? Let me move that guy a little out of the way. How do we break down molecules? We also have to be able to break down biomolecules. Do you remember at times where we talked about, what was it, anabolic and catabolic? Okay, we've talked about those. Anabolic was the building, catabolic was breaking down. So we have to be able to break down biomolecules into their building blocks. Think about when we undergo digestion. You eat a hamburger that is full of protein, carbohydrates, and fats. Your body wants to break those all down so that you can use the building blocks to build new muscle and to get energy. As we're breaking down the biomolecules, it is the reverse of a dehydration reaction. So we are basically undoing what we did. So if we had to remove a water during dehydration, what do we have to do to break them apart? We need to add water. When we add water to a polymer to break it into its monomers, we call this a hydrolysis reaction. A hydrolysis reaction. So, as we are taking monomers and building polymers, we do so by dehydration synthesis. We remove a water and connect the polymers together. When we are breaking the polymers down to monomers, we add water. We call this hydrolysis. When we add the water, we break it into its individual monomers. As you can see down here, okay, we have this polymer connected together just like we did before, our two smiley faces. All of a sudden we add the water and we break them back into the original polymers that we started with, don't we? So, can you tell me the difference between dehydration and hydrolysis? Okay? Who can tell me the difference? That's probably going to be a question. What's the difference between dehydration and hydrolysis? Jonathan? Dehydration is taking the water away to make a polymer, and You were close at the start. Break down the macromolecules into, okay, what were the smaller parts, the building blocks? Okay? You can look back. What were those called? Monomers. Excellent. So the hydrolysis is breaking the polymer back into the monomers. Okay? Now, here is the next slide. Okay, what I want you to do is, let me check this out here. Well, I thought I could click on that. Okay. Wait, I can. Let's check this out. Get bigger. Oh, didn't want to do that. Oh, all right. All right. Let's bring in another amino acid, and let's look at how amino acids can be bonded together. First, we're going to look at a process called dehydration synthesis. Dehydration synthesis is the way that these two amino acids are going to bond together and eventually make proteins. To do this, we're going to remove the H and the O from the carboxyl group. So the O is red, the H is white. And we're going to remove a hydrogen from the amine group. This gives us a spot here to attach and a bond there. So we're going to attach these two together at that point. And we have created, with the leftover, the H from here, the amine group. Here is the OH from the carboxyl group, and we have formed water. So what we've done here, is we put two different monomers. This one was one of the monomers, this one was the other. We put those two together, we have water given off, so we have a dehydrolysis reaction occurring. We've given off water and we've combined the two monomers. Boy, it's getting a lot worse here. I'm going to come over here and do it. The byproduct of this joining together, we have something called dehydration synthesis. Dehydration in the respect that water has been removed, and synthesis in the respect that we have built something. Synthesis means to build. So that's dehydration synthesis. How can we undo what we just got through doing? That process is called hydrolysis. Hydro meaning water, lyse meaning to cut. So we're literally going to add water to split this back. So we're going to disassemble our water. We're going to disassemble in the same place we took it apart. We're going to add this hydrogen back to this amine group. And we're going to add our OH back to this carboxyl group. And we just performed hydrolysis. We have separated two amino acids that were joined together into hydrolysis to split using water. All right, so does that make sense? Okay, just a little visual to see what was happening with these two different types of reactions, the hydrolysis and the dehydration synthesis. So what we're going to do, folks, is I am going to give you a cut, color, and paste over hydrolysis and dehydration. So open your INB to page 77. We're going to put this on page 77 of your interactive notebook.